Hello and welcome to this lesson about polynomial factoring. The learning target for this video is factoring out GCFs and factor by grouping. So this video is also going to act as an introduction to what factoring is. Now, if we think about that word, factoring, it's probably something you've done before. So for example, we say something like, what are the factors of 6? You'd write out a little list of 2 and 3, and then you'd say 1 and 6. Those are the factors. Those are the things that you can multiply together to make this number right here. Well, we're going to be doing the same thing, but with polynomials. And so when I introduce polynomials to you, I wanted to stress this idea that we're doing a lot of the same arithmetic that you've already done, the multiplying, the adding, subtracting, but instead of it just being solid numbers, it's with expressions. And so the same idea. What we're going to try to do is we're going to try to factor something like 2x squared plus 4x. We want to see if there's some sort of common factor there that we can maybe extract from it. And then why we're doing this, I'll explain a little bit, or that's for further down the road. So now let's talk about GCF. This is where I think all factoring should start. It stands for greatest common factor. And what we're going to do is we're going to focus on the GCF of monomials. So if I bring back that one I just had, 2x squared plus 4x. I want to zone in on these little monomials within my actual polynomial. And I want to ask myself, what is the GCF of each one of those? Well, you look at the numbers and then the variables separately. So my numbers are 2 and 4, and they have a common factor of 2. Then I look at the x's, and I ask myself how many x's are each one has at least. And each one has at least 1x. So now I've identified my GCF. What I'm going to do now is extract out that 2x. So this is where it gets a little bit confusing. You might see it and get it right off the bat, or you may not. So what we're going to be doing here is we're going to undistribute. So I'm going to take this 2x, put it here, and now I have to ask myself, what would I have to multiply my 2x by so that I would have 2x squared? That's going to be x. Do the same thing. What would I multiply my 2x by to get 4x? Well, that would just be 2. If I multiply those together, I get it. Now, some of you might be able to do this in your head. Others of you might be like, what are you talking about? How did you get that? And so here's how I actually did that. What I did is a little intermediate step where I essentially went 2x squared plus 4x, and then I divided it by 2x. That's how I figured out what was going to be in my parentheses here, and then eventually be replaced with 2x. So let's do another example. Let's try something like, let's not do 3x. Let's do 6x to the third minus 3x squared, and we'll leave it at that. Okay, so it won't always be done with polynomials, with binomials, but it's easy to identify with binomials. So that's why we'll start here. So again, what I want to do is take a look at what I have and ask myself, what is the GCF? So looking at the numbers, my GCF would be 3. Looking at the variables, it's going to be x squared. So now I have two options. I can just write 3x squared and sort of backfill the undistribution process. Here I will need to put a minus sign since it was minus there. All right. Or I could also take my 6x cubed minus 3x squared. And if you're not seeing it quite yet, you can then divide by, or each one of these by your GCF. So 3x squared and 3x squared. So here I divide 6 into 3. I get a 2. X cubed, x squared will leave me with just 1x. So that goes away, that goes away. And here, this is something that tends to trip up some students. These are the same thing. It doesn't become 0, it becomes 1, because the 3 and the 3 cancel each other out, the x squared and the x squared cancel each other out, and we put a 1 there. Because remember, we should be able to distribute this and get that answer right there. If I don't put that 1 there, I'm not getting 3x squared. All right, we'll do one final example. We'll make it complicated, hopefully complicated, so I don't know, makes them, or you can see what happens. Let's go with 8x cubed y plus 4x squared y minus 6xy. All right, hopefully this one looks a little bit different, and here we have a trinomial. But the thing is, regardless of how long the polynomial is, we could always do the GCF factoring method. So GCF, and I'm going to write it underneath. Again, I look at all my numbers, and it has to be the GCF of all 3 of these. It's going to just be 2. I look at the x's. The bare minimum of x's I have is 1, and the same idea applies for my y's. So when I write my parentheses, I'm going to have to fill in 3 spots, something plus something minus something, and on the outside is 2xy. Again, if you want, you can divide, or sometimes we can do this in our head, and after a while you will get better at it and you will be able to do it in your head. And let's see here, we'll get 4x squared, 2x, and then minus 3. Oh, that's 6, not 3. 3. And there we go. We've written it down, or broken it down to its factors. And so that's the GCF method. Now, let's talk about factor by grouping. Now, I'm going to be honest. I'm not a big fan of factor by grouping. It has its uses, but they're few and far between, is the nice way to say that. Now, usually, you're going to need 4 terms to factor by grouping. And the other thing that we can take out of this idea of factor by grouping is that sometimes a GCF could be a binomial. And you'll see that in a second here. But let's just say we have something like x cubed minus 2x squared plus 5x minus 10. Now, what we're going to do is break this up into 2 little groups here. And odds are you're going to want the larger exponents on the left and then the smaller exponents on the right. And then we're going to see what we can extract here. And if we're lucky, we're going to get something similar to pop up. So here, I notice there's a common factor of x. So I will factor out an x just in that little group to get x squared. Actually, no, there's an x squared, so I can do x squared. Take out x squared to get x minus 2. Plus, and now I'm going to see what I can factor out of this one, and I see a common factor of 5, so I'll take out a 5, comma, x minus 2. Well, here, I have something common. So I could actually use that GCF method to extract this x minus 2, and here's where it's going to get a little bit mind-bendy for some of you. I'm going to factor out that x minus 2, so I'll have outside here x minus 2. Then immediately I'm going to need parentheses, and I have to backfill that with something. And what I fill it with is this x squared and this 5. So x squared plus 5. And there I've factored. So that is a method we have in our tool belt. It's where you can have multiple terms and you can extract you can focus on a part of them, and hopefully these match up. If these don't match up, there's no point to it. But odds are if you're asked to factor by grouping, they're going to match up. So just wanted to go over that so that way you're familiar with it. Good luck with your homework or practice, and let me know if you have any questions.